The next point, we should ensure whatever we see is clear.
That means work is being done, we can see that it is in opposite direction.
My esteemed students, I welcome you to another exciting segment of our lesson in mathematics. I remain Mr. Fidelis Yakubu. By the grace of God, we are continuing with a new topic we started in our previous lesson, known as the simultaneous linear equations. And the subtopic is method of solving simultaneous linear equations, in which we started with the elimination method, example number 1. We are continuing with example number 2 today. My dear students, I want you to recall there were two basic rules I gave you in our previous lesson regarding the simultaneous linear equations under the elimination method. Number 1, make sure the equations are balanced. Make sure the equations are balanced. What do we mean by balancing equation? That means if you choose to balance the variable x first, then you should make sure that the coefficient of x in the equation 1 must be equal to the coefficient of x in the equation 2. That means your x is balanced. And your y on the same case, if you are balancing it, then the coefficient of y in the equation 1 must also be the same in equation 2. So that is rule number 1. Then number 2, in which you also need to take note because it's very vital. If the signs of the balancing terms are the same, then you are to subtract the equations. That is, if you have equation 1, the balancing sign is positive, and equation 2, the balancing sign is also positive. That means the two signs are the same, so you are to subtract the equations. So also, if they are both negative, that is, equation 1 carries the negative sign of the balancing, and equation 2, the balancing sign is also negative, they are also the same. You are also expected to subtract the equations. But if the signs of the balancing terms are different, then the result will be the converse. That is, you are to add the equations. For instance, if you have plus, minus, or minus, plus as the balancing signs, then you are to add the equations. Then, under the elimination method, we have different type of examples. So in our previous lesson, we treated the first type of example, and today we are going to treat the second type of example as follows. That is example number 2. Solve the equation. Solve the equation. 2 over x minus 1 over y equals to 3. 2 over x minus 1 over y equals to 3. And 4 over x. Please, this very number 2, I only have example number 1. These two equations, I'm treating them as the same. That's why we say they are simultaneous. They are not numbered 1 and 2. It's only 1 there, please. So I take that again. 2 over x minus 1 over y equals to 3. 2 over x minus 1 over y equals to 3. Then the next equation is 4 over x plus 3 over y equals to 16. 4 over x plus 3 over y equals to 16. When you look at the two equations, then you can agree with me that it's different from the previous one that we work. So in this type of equation, you can see both of them are fractional on the left. So you need to translate them in another form to give you a room to work them properly. In mathematics, if you are taking the first one, that is 2 over x, mathematically, one number can you multiply by 2 as a numerator to still give you 2. I take that again. One number can you multiply by 2 as a numerator to still give you 2, and the number is 1. The number is 1. I am saying 2 times 1, the answer is 2. And so that is why I now wrote 2 times 1 over x, because 2 times 1 is still 2. So 2 over x can be written mathematically as 2 into 1 over x. Or you can simply put it as 2 times 1 over x. please, it's very, very paramount. Because if you don't understand it, there's no how you can go further to solve the equations. So I take that again. 2 over x mathematically can be written as 2 times 1 over x, which simply means 2 into 1 over x. Then minus, the second fraction is 1 over y, which is written correct. 1 over y equals to 3. 1 over y equals to 3. So I name it equation 1. Then the second equation, 4 over x plus 3 over y equals to 16. The numerator is 4 in the first fraction, which is 4 over x. The numerator is 4, it's not 1. So it also needs to be translated into another form to enable you to solve this, to enable you to solve the equation accordingly. So a number that you can multiply by 4 to still give you 4 is 1. A number that you can multiply by 4 to still give you 4 is 1. So now, the first fraction becomes 4 times 1 over x. 4 times 1 over x. Then, the second fraction is 3 over y. A number that you can multiply by 3 to still give you 3 is also 1. A number that you can multiply by 3 to also give you 3 is still 1. So now, 3 over y can also be translated as 3 times 1 over y. 3 times 1 over y, which mathematically can be written as 3 into 1 over y. 3 into 1 over y. So the equation now becomes 4 into 1 over x plus 3 into 1 over y equals to 16. And I name it equation 2. The next step, you are to bring the two equations together and solve them simultaneously. So the first one is 2 into 1 over x minus 1 over y equals to 3, equation 1. Then 4 into 1 over x plus 3 into 1 over y equals to 16, equation 2. Now, recall the first rule, which says make sure the equations are balanced. Make sure the equations are balanced. Now, in this case, I chose to balance y. I chose to balance y. You can also choose to balance your x. But for me, I balance my y. Now, in balancing y, in equation 1, the coefficient of y of 1 over y is minus 1. The coefficient of 1 over y is minus 1. So what I did, I multiply equation 2 by minus 1. I multiply equation 2 by minus 1. And in equation 2, the coefficient of 1 over y is 3. The coefficient of 1 over y is 3. So I multiply equation 1 by 3. I multiply equation 1 by 3 to balance them. Now, if you multiply equation 1 by 3, then you can have the first term, that is 2 into 1 over x, multiplied by 3 becomes 6 into 1 over x. 2 into 1 over x multiplied by 3 becomes 6 into 1 over x. So also, 3 multiplied by minus 1 over y. 3 multiplied by minus 1 over y will give you minus 3 into 1 over y. Will give you minus 3 into 1 over y. And 3 times 3, the answer is 9. 3 times 3, the answer is 9. Let's move to equation, and I name it equation number 3. I name it equation number 3. Then let's pick equation 2. I said to balance y, we multiply equation 2 by minus 1. We multiply equation 2 by minus 1. So 4 into 1 over x times minus 1 will give you minus 4 into 1 over x. Will give you minus 4 into 1 over x. So also, minus 1 multiplied by minus 3 will give you minus 3 into 1 over y. You have minus 3 into 1 over y. You have minus 3 into 1 over y. Then equals to 16 in the equation 2. If you multiply 16 by minus 1, it will give you minus 16. 16 multiplied by minus 1, it will give you minus 16, and I name it equation 4. Now, the next step is you consider the signs of the balancing terms. That is rule number 2 under the elimination method. Consider the sign of the balancing term. In the first equation, the sign of the balancing term, that is 1 over y, in equation 3 is negative. In equation 3 is negative. So also, the sign of the balancing term, that is y, in equation 4 is also negative. It's also negative. What is the rule saying? When the signs are the same, we are to subtract the equations. When the signs are the same, we are to what? Subtract the equation. Now, in subtracting the equation, you can choose to say equation 4 minus equation 3. You can choose to say equation 4 minus equation 3, or equation 3 minus equation 4, or equation 3 minus equation 4. You all arrive at the same answer in whichever way. But to me, I chose equation 3 minus equation 4. I chose equation 3 minus equation 4. What is my equation 3? 6 into 1 over x. 6 into 1 over x, that is the first term there. Then minus, look at the minus representing equation 3 minus equation 4. Look at the first minus there, is standing for that. Then the second minus is representing the coefficient of 1 over y in equation 4, which is minus 3. I repeat that for better understanding. We are subtracting the equation. That is equation 3 minus equation 4. So the first term is 6 into 1 over x minus, which represents equation 3 minus equation 4, the first minus there. Then the second minus is, you can now see that the coefficient of 1 over y in equation 4 is negative 3. It's negative 3. That's why you can see the second negative there. You can see the second negative there. You can see the second negative there. Then into 4, minus 4 into 1 over y is now equals to 9, the first 9 there, then negative representing the subtraction there, then minus 16. The 16 is carrying a negative coefficient. So that gives you minus 16. Now, the first on the left, the two middle sign, that is negative, negative, will give you positive. So 6 into 1 over x plus 4 into 1 over y. 6 into 1 over x plus 4 into 1 over y. And 6 plus 4 will give you 10. So I now have 10 into 1 over x. I now have 10 into 1 over x. Then the right-hand side, which is 16, then the two middle sign will give you positive, and the last number there is 9. So 16 plus 9 will give you what? Will give you 25. 16 plus 9 will give you 25. Now, to find the value of 1 over x, we are to divide both sides by its coefficient, and its coefficient is 10. Its coefficient is 10. So on the left, I now have 10 into 1 over x over 10. And on the right, I have 25 over 10. I have 25 over 10. On the left, 10 divided by 10, you'll be left with 1. You'll be left with 1. Then 1 times 1 over x, you'll be left with 1 over x. 1 times 1 over x, you'll be left with 1 over x. Let's come to the right now. 25 divided by 10 will give you 5 over 2. Why is it 5 over 2? When you reduce 25 over 10 to its lowest term, the HCF of 25 and 10 is 5. The HCF of 25 and 10 is 5. So 5 into 10, the answer is 2. That's why you can have the denominator as 2. Then 5 into 25, of course, the answer is 5. 5 into 25, of course, the answer is 5. So the new question becomes 1 over x equals to 5 over 2. 1 over x equals to 5 over 2. But don't forget, we are looking for the exact value of x. We are looking for the exact value of x. How then can we get the value of x? We are going to get that by cross multiplication. By cross multiplication. That is, x times 5, the answer is 5x. X times 5, the answer is 5x. And 1 times 2, the answer is 2. 1 times 2, the answer is 2. So the equation is 5x equals to 2. 5x equals to 2. Now, to get the value of x, we have to divide both sides by its coefficient or its multiplier, you can put it. The multiplier of x there is 5. The multiplier of x there is 5. So that becomes 5x over 5 equals to 2 over 5. 5x over 5 equals to 2 over 5. Then, 5 divided by 5, the answer is 1. 5 divided by 5, the answer is 1. So on the left, you have 1 times x, and the answer is x. 1 times x, and the answer is x. Now, the right becomes 2 over 5. The right becomes 2 over 5. Conclusively, our x is equals to 2 over 5. Now, having got the value of x, we are to determine the value of y. Now, substitute the value of x in equation 2 for y. Substitute the value of x in equation 2 for y. You can also choose to substitute that in any of the equations. You arrive at the same answer. But I chose equation 2. Now, what is equation 2? 4 into 1 over x plus 3 into 1 over y equals to 16. 4 into 1 over x plus 3 into 1 over y equals to 16. Now, what is the corresponding value of x? The corresponding value of x is 2 over 5. Is 2 over 5. So the first expression now becomes 4 into 1. 1 is the numerator. Then the denominator is the x there. The denominator is the x there. And what's the value of x? 2 over 5. The value of x is 2 over 5. That is why it is clearly written 4 into 1 divided by 2 over 5. 4 into 1 over 2 over 5. Plus the second expression on the left. 3 into 1 over y. 3 into 1 over y equals to the right-hand side, which is 16. Equals to the right-hand side, which is 16. Now, 4 into 1 divided by 2 over 5 can simply be written as 4 times 5 over 2. 4 times 5 over 2 by the rules of division. Because division always changes to multiplication. And as soon as you change it to multiplication, then you have to invert the fraction. You have to invert the fraction. The denominator becomes the numerator, while the numerator becomes the denominator. So that is why that expression there turns out to be 4 into 5 over 2. Or you can simply put it as 4 times 5 over 2. Now, by simplification, 2 into 2 is 1, and 2 into 4 is 2. 2 into 2 is 1, and 2 into 4 is 2. So 2 times 5 will give you 10. 2 times 5 will give you 10. Then the second expression now, which is plus 3 into 1 over y equals to 16. Plus 3 into 1 over y equals to 16. Now, don't forget, we are looking for the corresponding value of y. We are looking for the corresponding value of y. So now, when plus 10 on the left, when plus 10 on the left crosses to the right become minus 10. When plus 10 on the left crosses to the right becomes minus 10. Recall that when a number crosses an equal sign, either to the left or to the right, the sign changes. It's a standard rule binding in mathematics. When a number crosses an equal sign, then the sign changes either to the left or to the right. That is, negative becomes positive and positive becomes negative. So that is why plus 10 crosses to the right becomes negative 10. And 16 minus 10 will give you 6. 16 minus 10 will give you 6. 16 minus 10 will give you 6. We are looking for the value of y. So now, to get the value of y, we are to divide both sides by 3 in order to get the value of 1 over y. Because the coefficient of 1 over y is 3. The coefficient of 1 over y is 3. So, divide both sides by 3. By doing that, 3 divided by 3, the answer is 1. 3 divided by 3, the answer is 1. So, 1 times 1 over y, the answer is 1 over y. 1 times 1 over y, the answer is 1 over y. Move to the right now. 6 divided by 3, the answer is 2. 6 divided by 3, the answer is 2. So our equation becomes 1 over y equals to 2 over 1. 1 over y equals to 2 over 1. Where is 1 coming from? 2 as a whole number can be written fractionally as 2 over 1. 2 as a whole number can be written fractionally as 2 over 1. Why? Because 2 divided by 1, the answer remains 2. 2 divided by 1, the answer remains 2. Or alternatively, any number divided by 1, the answer equals to that number. Any number divided by 1, the answer equals to that number. So I now have 1 over y equals to 2 over 1. How can I get the corresponding value of y? Of course, I'm going to cross multiply. I'm going to cross multiply. And by doing that, y times 2, the left, the answer is 2y. Y times 2, the left, the answer is 2y. And 1 times 1, the right, the answer is 1. 1 times 1, the right, the answer is 1. I am looking for y. The multiplier of y here is 2. The multiplier of y here is 2. So I am to divide both sides by its multiplier, that is 2. So the left becomes 2y over 2. The left becomes 2y over 2. And my right, of course, becomes 1 over 2. My right becomes 1 over 2. 2 divided by 2, the answer is 1. 2 divided by 2, the answer is 1. And 1 times y, the answer is equals to y. 1 times y, the answer equals to y. And of course, my right remains 1 over 2. My right remains 1 over 2. Conclusively, my x is equals to 2 over 5, and my y equals to 1 over 2. My x equals to 2 over 5, and my y equals to 1 over 2. Before we close for the day, I have an assignment for you. Make sure you work this assignment and practice harder for better understanding. Assignment, solve the equations. 2 over e minus 3 over f equals to 1. 2 over e minus 3 over f equals to 1. And the next equation is 8 over e plus 9 over f equals to 1 over 2. 8 over e plus 9 over f equals to 1 over 2. The references of my research include 1. New Journal Mathematics by M.F. Macri, Z.I. Chima, G.U. Garba, et al. New Journal Mathematics by M.F. Macri, Z.I. Chima, G.U. Garba, et al. Then number 2, Questions and Answers by Wayek in Mathematics. Questions and Answers by Wayek in Mathematics. I remain Mr. Yakubu Fidelix. You can get me through this contact 080-2525-5287. Mr. Yakubu Fidelix, 080-2525-5287. Stay home, stay safe, and keep learning well. Thank you.